So thank you everyone for coming. So today's workshop will be covering how to make your data fair. And so if you're not familiar with the FAIR principles, essentially what they are is it's four guiding principles that are meant to sort of shape how you share your research data in a way that encourages transparency and most importantly ensures that data has value and is reusable for other people down the line. And so today we'll be covering, in more detail what exactly are the FAIR principles and more importantly, why should you care about them? And then we'll break down each of the principles one by one and each of the elements within them. And then we'll be talking about some recommendations and sort of best practices to help you practice these FAIR principles when you're sharing your data. Throughout the presentation, I'll be showing off some demos of some helpful tools and websites related to data sharing and FAIR data. And then at the end, we'll talk a little bit about our library data services and about how we can help you with your data sharing and things like that. And so speaking of data sharing, I thought it'd be helpful to talk a little bit about why sharing data is important and why we're talking about sharing data. And so the key thing about sharing data really is that it enhances research reproducibility, transparency, and validity. And of course, a lot's been said about the replication process, the replication crisis and all that type of thing. I'm not going to rehash it all here, but suffice it to say that sharing your data really does improve the scientific process. It makes it so people can replicate your results and makes it transparent. And it just increases trust in research overall. Another really good benefit of research sharing and of data sharing is that it helps to accelerate the pace of research by allowing people to build upon your data, to combine data sets, and to really just do more work with that data without duplicating effort. Research has shown that there is on average around a 17-year time lag between research and clinical practice. And so an important part of data sharing is helping to reduce that time lag and make sure that the research we're doing in medicine and the health sciences is translating into better patient care at the end of the day. In addition, there's lots of personal benefits to data sharing. Research has shown that articles that have shared data sets attached to them get greater citations than articles without them. And of course, data sets themselves are citable and are another research output. That can look quite good on a CV for tenure review, that type of thing. So overall, we share data to advance knowledge, promote equity, and practice good scientific principles. Of course, many of you will be aware that the NIH, as of January 25th, has instituted a new data sharing policy that prefers sharing data whenever possible for NIH-funded research. And of course, late last year, there was also the memo that came out of the White House Office of Science and Technology Office, which is really promoting data sharing and public access to research across all federally funded research. And so you can expect that a lot of additional federal research funders and by extension private research funders will be following the NIH's lead on that matter. So when it comes to funded research and sort of research trends overall, I would expect to see more data sharing policies in place from funders and publishers and things like that. And so let's talk a little bit about what exactly are the FAIR principles. And so what they are is they're a set of guiding principles to help ensure your research data is shared in such a way that enhances its reproducibility and transparency. In essence, what the FAIR principles are about are going beyond just sharing your data and making sure that your data actually has value once it is shared. Because you can post a public data set and it's always good, but if it isn't described well, people can access a data set if they can't find that it's out there, that its value and its use in future research is of course limited. And so the four FAIR principles that we'll talk about each and more in depth later is that data needs to be findable, needs to be accessible, it needs to be interoperable, and it needs to be reusable. And so sort of to simplify it, there's this good quote here that I like, which is that FAIR in essence is ensuring your data is well structured and in an open format, then depositing it into a reliable repository with good metadata and applying an open license. I particularly like this quote because it really simplifies down FAIR and makes it clear that it's really just a core set of a couple of practices that are fairly simple practices at the end of the day that if you incorporate into your workflow, incorporate into your research data sharing practices will really promote better research and increase the value of the research you're doing. And so before we dive in any deeper here, I think it's important to note that FAIR isn't necessarily the same thing as open. The FAIR principles ask that your metadata is whenever possible available in the repository, and there's some sort of statement that makes your data accessible upon request whenever it's feasible or legal. But really the important thing to know here is that the FAIR principles are sensitive to the fact that not all data can be shared openly and publicly. This is, of course, especially true in the health sciences, where we're dealing with patient data, that a lot of patient privacy issues, HIPAA regulations. And so, I know that not all data necessarily wants to be shared openly in a public repository, and the FAIR principles are not asking you to do that. They're just asking you to be as open as you can be and to make data accessible when it makes sense and when it's legal to do so. So now I want to dive into the first of the principles, which is findable. In essence, this principle means that if no one can find your data, then no one can use it, right? And so there's not much value to sharing data if nobody can find it, if nobody knows it's out there. And so there's really kind of two key principles behind making your data findable. The first of which is using persistent identifiers. Now, chances are you're familiar with things like DOIs, PubMed IDs, that type of thing is attached to journal articles. And these are all what we call persistent identifiers. And a persistent identifier is basically a link that is permanent and stable and always goes to the same place or object. And so the premise behind a DOI, for example, is that, well, articles can live in a lot of different places, on journal websites, on decision repositories, and PubMed Central, et cetera, et cetera. The DOI always goes to one place and is the most sort of stable, permanent record of that article. To make your data findable, but generally the best principle is going to be to assign a DOI, just like you do for an article, to your data sets themselves. Now, this sounds kind of complicated, but in practice, the vast majority of repositories will allow you to assign a DOI upon depositing it in the repository. And so assigning a DOI to your data set is usually as simple as just finding a good, reputable, well-known repository, and they'll take care of the rest. In the small number of cases where a repository cannot assign a DOI, however, that is something the library can help with and work through with you. Now, the second important part of making your data findable is in applying rich metadata to your data. Essentially, metadata is data about data. And so if you've ever looked at, like a PubMed article, the PubMed has the author, the date of publication, the journal, the abstract, the keywords, all that kind of good stuff. And essentially what that is metadata, right? It's telling you all the information you need to know to give context to the article, to find the article somewhere else, and to understand the article is relevant to your research needs. And essentially, when you're publishing your data, you want to make sure you're doing the same things. You want to make sure you're applying all this rich metadata, and basically giving all the information that someone would need to know to find and understand your data. And we'll be talking more about metadata later on, sort of throughout this workshop. But for now, the key takeaway really, and the most important takeaway, is that metadata is just a way of contextualizing your data sets to make sure that it's useful for other people. And like I said before, the FAIR principles do not necessarily require you to make your data openly accessible. Instead, the important part is that your metadata is online in an accessible repository. So in instances where data cannot be shared, best practices would still be to put the metadata for it in a repository, but then make the data accessible upon request for legitimate research purposes and things like that. And so really the key takeaways for making your research findable is really just two things, which is to choose a good repository and to give it good metadata, both of which we'll talk about a little bit more detail later on. Now, the second of the principles is that your data needs to be accessible, which basically means that for users to be able to use your data, they need to be able to either access the data itself or be able to access enough information about the data to determine whether or not it's relevant for them. And so there's a lot of different ways of approaching this. Like I said before, persistent identifiers are another important part of that because clicking on them will always take you back to the data set. That's part of making it accessible. Like I said before, the metadata should always be accessible regardless of what the data set can be. And of course, you're always welcome to use closed access repositories or put access controls as needed. Another important part of making your data accessible is following sort of established technical standards that allow sort of data to communicate with each other and allow accessibility concerns, that type of thing. But really the key takeaway for all of these points of the accessible principle is that they're going to be addressed by just choosing a suitable repository, because a good repository will, give you persistent identifiers. It'll have its metadata accessible and easily findable in Google Scholar, Google Dataset Search, that type of thing. And the backend concerns like technical standards will be addressed by choosing a good, repeatable repository as well. And so I did want to spend a little bit of time now talking about how to choose a suitable repository and where to look for repositories. Because you may have already noticed a theme here, which is that a lot of the FAIR principles are addressed not necessarily by you individually, but by just choosing a good repository. And so I did want to show a couple of links here. First is the NIH supported repositories list. And so I will share out these slides when I share the recording of the workshop as well. But basically, so you have the links. But this list is a list of all the repositories or data that are supported in some way, shape, or form by the NIH itself. Now, it's important to note that if you are doing NIH-funded research and are subject to their data sharing policy, their preference is to choose an NIH-supported data repository if there is one available for your data. Now, these NIH data repositories tend to be a bit more focused than some of the broader repositories. They tend to focus either on research coming out of a specific institute or center, or they have a specific disciplinary focus, or sometimes they focus on specific types of data, like imaging data and things like that. And so if you're doing NIH-supported research, your first step should always be to go to this list and see if you can find any relevant databases based off your file type or your research area that are relevant to your research area. In addition, however, even if you're not doing NIH-funded research, many of the NIH-supported repositories do accept open deposit of research, so long as it matches sort of the scope of the repository. And so these are very well-regarded, well-supported repositories that will have good longevity. And so they're a good starting point for any research that sort of falls into the health sciences more broadly. Another important thing that you should be aware of is called the Generalist Repository Comparison Chart. And so you may have heard of data repositories such as Dryad, Zenodo, Harvard Dataverse, Vivly. All of these are what we call generalist repositories, which is to say that they don't have the sort of narrow disciplinary focus that the NIH repositories do. Rather, they accept data in pretty much any discipline. And so these are going to kind of be your second choice if there are not NIH-supported repositories available. And this comparison chart is really helpful because not only does it go over all of these sort of most well-known and most well-utilized repositories, they also go over specific helpful information like what are the size limits for the file types, what licensing options do you have, what does it cost to the researcher? If anything, there are plenty that will allow small and medium data sets to be published completely for free. And so it doesn't go over sort of all the helpful information you would need to help decide which of these generalist repositories are most relevant for you. The repositories in this chart also act as a very good short list of well-known reputable repositories that the NIH and the research community more broadly has accepted. I did also want to mention SIL ScholarWorks, which is our recently launched institutional repository. We are set up to accept small data sets. And so if you do have a smaller data set that isn't finding a good home, either in an NIH repository or generalist repositories, we can also be a good option as well. And if you did ever want to share any data sets in our repository, just reach out to me directly and I can help you get set up for that. And the last link I did want to point out is Re3 Data, which is the registry of research data repositories. And kind of like what it sounds like, it's essentially a search tool to identify data repositories in a specific field or area. So as an example here, I'm just searching for neurology, considering a good list of various different types of databases and repositories that would accept data deposits in the neurology area. Is that this can also be a very good way to find relevant discipline-specific databases within your research topic as well. And of course, the last thing I did want to mention is, let's go back. The last thing I did want to mention is that the library, of course, is a very good research for this, is a really good resource for this. If you are sort of overwhelmed with the number of options, I know it's a lot. Don't worry, you are always more than welcome to email us. Just give us some information about your research, your data set, your research topic, and we can help you identify what repository will be a good fit for your research data. And so the third principle I wanted to talk about today was interoperable. Basically, what this means, the data should be in formats that makes it easy for them to be reused by others and to be used by different programs. And basically, there are three ways of making this happen. First is through the use of open file formats. Second, to the use of metadata standards. And third, to the use of controlled vocabularies. And each of these we'll talk about in a bit more detail. So first off, open file formats. It's important when you're sharing your data to use open, non-proprietary file formats that are easily accessed by lots of different types of programs. So think of things like .csvs, .rtfs, .pdfs. These really generalist sort of file types that are openable by pretty much any program out there. Oftentimes they'll be different than the file format you work in. For example, most people work in the Excel file format for their spreadsheets because pretty much everyone uses Excel these days. However, when you're sharing your data, it'd be better to share it in the .csv file format rather than the Excel file format. And the reason why is that in the long term, you never really know what kind of technology changes might happen. Sure, everyone right now has access to Excel, everyone uses Excel, but 20 years down the road, that may not be true. And even if you're looking sort of within Excel itself, the 10-year-old Excel file versions these days are often kind of break when you open them in newer versions of the software, just because so much has changed with these proprietary file formats. Well, things like .csv are very consistent, they're stable, they'll be openable by anything. So it's a better sort of long-term archival option. Now note that this goes double if you're using any sort of specialty file formats or specialty proprietary software, which is that whenever possible, try to get those in open file formats for long-term preservation. Just because oftentimes with these more niche file formats, it's more niche software programs, they can often go out of date very quickly, be unsupported a couple of years down the line, that type of thing. And open formats help to avoid these kinds of issues. The second part of making your data interoperable is using metadata standards. Essentially, we were talking about metadata earlier, and what metadata standards are just sort of a standard way of labeling and describing your metadata and using your metadata that makes it easier for different systems to communicate. In particular, for example, using good metadata standards will make it easier for other repositories to crawl for and identify your data. Like, for example, Google Scholar, Google Dataset Search, using established metadata standards will help them find your data and make it more easily findable. Now, I have a couple of links here that I'm not going to necessarily show off, but the two most common standards you're likely to encounter is going to be either Dublin Core, which is sort of a general metadata standard used by lots of different things, and the DataCite Schema, which is a metadata standard developed specifically for data sets and data sharing. And of course, there are specific metadata standards that apply to different disciplines and subdisciplines and things like that. Now, these links are pretty in the weeds, which is why I'm not going to show you them. But sort of the key takeaway here is that the jargon around metadata makes it seem a lot more complicated than it is. In reality, most repositories will make it very clear what metadata standards are using, and they'll make it clear what kind of information they want for each metadata field that you're entering. In addition, like I said before, the key thing to understand about metadata is that you want to share any information that makes it easier for others to find and use that data. So if you just sort of keep this external perspective in mind to sort of provide thorough information for that purpose, you'll do a pretty good job, regardless of not necessarily know the details of the standards. That being said, this is also what librarians are for. Whether we like it or not, all librarians are trained in metadata and metadata standards. And so if you do have questions about making your metadata accessible, about following the standards, we're more than happy to help in that
Everything's
regard.
good. Yeah. Super.
Oh, I think we're
Thank
getting
you
some
so much.
background noise.
You too. Bye.
All right, so the last aspect of making your data interoperable is using controlled vocabularies. And so what a controlled vocabulary is essentially a set vocabulary that uses standardized terminology for a given field or topic. Those of you that do a lot of in-depth PubMed searching are probably familiar with MeSH. And MeSH is a type of controlled vocabulary. And basically, when you have the option to describe your data either with keywords or when you cite subject areas, do try to use these controlled vocabulary terms, as it does create just a bit more standardization, makes it a bit easier for people to find the type of content they're looking for. It is important to note that there's a lot of different terms for controlled vocabularies. So you may also see words like thesauri, ontologies, subject headings, and these all refer to the same thing. And so just knowing sort of the controlled vocabulary terms in your discipline will be very helpful for describing it in a way that's going to make it easier for people to find your data. And lastly, the last principle is reusable. And really what this comes down to is, while data sharing is kind of the last step in the research process for you, it can often be the first step in someone else's process, right? Because someone else may be able to see value in the data that you didn't see. They may be able to combine it with other public data sets to discover new discoveries. And really, this is what sort of the FAIR principles are all about at the end of the day, is making the data usable by other people. And of course, that reusability, like I said at the beginning, is really important for research reproducibility and validity, and really just increasing the rigor and trust in research. And so there's kind of two key things to making your data reusable. The first is providing clear documentation, and the last is providing clear information around licensing and ownership of the data. And to start with documentation, there are kind of three primary things you're going to want to do to document your data and make sure it's reusable. First is to use README files, which are a type of plain text file that's provided with the research data that basically gives all the necessary context you need to understand and use that data. The second is data dictionaries. No, apologies, there is a typo here. But a data dictionary essentially is a dictionary that accompanies research data that provides all the information you need to understand that data. So it's going to be things like, what are your variables? What are the acceptable range of those inputs? What acronyms are you using? What definitions are you using? What abbreviations are you using? Basically, any information you need to understand the raw data, you can put in the data dictionary. And lastly, we have file naming and structure, which is giving clear descriptive titles to your files that can be understood by anyone, and organizing your files in a clear way that makes it easy to find what you're looking for or what other researchers are looking for. So to talk about all of these in a bit more depth, README files can kind of fall into a couple different types. First is sort of general project files. These is going to be your high-level README files that will describe the overall organization and approach to your research, who is responsible for what instruments are used, what timeframes are used, what type of data was collected and why, was the research funded. Basically, anything you need to know at a high level that gives context to the research and its data, you would put in that general project file. Now, README files will often take the form of specific data files as well. And so they'll accompany specific data sets or specific chunks of data. And basically, they will describe, the contents of the data set. What date and time formats are you using, what measurements are you using, what are the acceptable values for that data, how, when, and why was the data collected. Basically, anything that gives context to that data and facilitates its use. But then lastly, you may also have README files for analyze or process data files that will basically talk about how the data was processed, what software, code, or tools were used to process the data. It basically will walk through the process of going from your raw data to your process data so people understand the process that was undertaken to create those final data sets. And so this is just some tips for data dictionaries and kind of information that will be within them. So like I said before, names and definitions of data, what are the properties of each data element, what acronyms and abbreviations are used, how is missing data coded, what is the relationship between these datas, between different types of data, and basically anything else you need to understand and use that data. And lastly, of course, file naming. It is important when you're naming your files to document, usually in your README file, what your file naming convention is, and to make sure you're sticking to that convention throughout the research project. So that includes things like having consistent order, using consistent abbreviations that are defined, and of course, just general good practices for file naming, like using underscores instead of spaces, not using special characters, and using standards for dates that are clear and internationally understood. An important part of file naming as well is using version numbers to make sure that people understand sort of the flow of time over the project, and that it's clear when different data was collected and sort of what their sequence is. There's also, of course, how you structure your files. And there's a lot of different ways to structure files. And basically, how you do it will depend on the project. So you can do it, by project type, by type of data. If you have lots of raw data, you may even do a different folder for each day, that type of thing. But the important thing really is that the file structure makes sense for the project, that it's consistent, and that it's all sort of stored in one location with regular backups. Now, the other aspect of making your data reusable is around licensing and ownership. And basically, it's important that it's clear who made and who owns the data. And this is also information, for example, they would put in a README file. Another important thing, too, is understanding under what license that others are allowed to use the data. So regards to ownership, this can be kind of complicated, especially because institutional funder policies might impose data ownership in different ways that may take data ownership away from the author. However, in the vast majority of cases, researchers are allowed, if not required even, to share their research data. Now, it's important to know that data copyright is pretty messy. It's not going to go into all the details here, but the core things to understand is that raw facts cannot be copyrighted. And so what that means is that a lot of data is actually not copyrightable at all, because it is, at the end of the day, most often just recording raw facts. That being said, the creative elements of a data set, like its organization, its coding, data visualizations of an article, all of these can be copyrighted. And so essentially, because data copyright's kind of messy and because parts of it are copyrighted and parts of it aren't, licenses are generally used to give blanket reuse permission and to eliminate that kind of ambiguity. And so the two most common types of licenses you'll see applied to data are CC0 license and CC BY licenses. And so if you're not familiar, CC0 licenses are a way basically of dedicating something into the public domain. And so if a data set is giving a CC0 license, that means it's how public domain work. There is no copyright applied to it anymore, and anyone can use it for any purpose as they see fit. You might also see CC BY licenses, which is a pretty wide use license that allows people to use the data freely without limitations, so long as they provide attribution back to the original author. And of course, in the context of research, the attribution most often takes the form of citation. But it's important to understand these licenses, not only for when you're maybe reusing other people's data, but oftentimes because different repositories may either impose a license in all their data sets. For example, some of them by default just give all the data sets in the repository CC0. So it's important to understand when you're depositing that you're giving up this copyright, that you're giving up your sort of copyright to the work. Additionally, some repositories will allow you to choose what type of license you want. And so if attribution is particularly important to you, you want to make sure you double down on that. You may want to choose to apply a CC BY license over a CC0 and things like that. And of course, if you have any questions about licenses or that type of thing, that's something that can also help you navigate here at the library. And so I wanted to sort of revisit this definition I talked about earlier about FAIR, which is, the simple definition is to ensure your data is well structured in an open format, then deposit it into a reliable repository with good metadata and apply an open license. And so having gone through all the elements of the FAIR principles, I wanted to sort of revisit this definition. Because like I said, this really does boil it down to a couple of key good practices that are your main takeaways from today, which is, to use open file formats, to use good file naming and structure, to choose a good repository, and then to describe your data well with good metadata and clear documentation. And then lastly, at the end, to understand and apply an open license. And I did, before I go forward, wanted to point out a couple of helpful tools. First here is the FAIR self-assessment tool. And this website basically is an interactive checklist that allows you to sort of go over each of these elements and make sure you're following these FAIR principles. And this really just boils it down to you and makes it easy to assess how fair your data is and to just use this as sort of a guiding checklist when you're sharing your data. The other website is fairsharing.org, which is a fair bit more involved. Essentially, fairsharing.org is a online database of information related to fair sharing. So that includes things like funder and publisher data sharing policies. It includes things like a list of repositories and databases that are used for data sharing. And it includes a lot of standards, such as metadata standards, technical standards, that type of things. All these things go into fair sharing. And so sort of as an example, if we just search neurology, you can see that we're coming up with different repositories. We're coming up with controlled vocabularies. We're coming up with different types of ontologies, data standards, all these different things that are relevant to fair sharing are in sort of in this large comprehensive database. And so, like I said before, if this is a bit overwhelming to you, don't worry. We can always help sort of navigate you through this. But if you do want to get into the weeds, some really helpful tools to learn more on your own. And so really the last thing I want to make sure we touched upon today is talking a little bit about our library data services. And so it's important to know that all the things we talked about today that we are here to help you with. So we can help you choose and apply a metadata standard, we can help you identify a suitable repository for your data. We can help you understand data documentation. We can help you choose your data formats and file types. We can help you understand and choose data licenses, and really anything else related to data sharing, we are more than happy to help you with. And so I did just want to point out that my email is here, cjgarcia@atsu.edu. You're always more than welcome to email me directly if you have any questions related to data sharing or the FAIR principles more broadly. And lastly, I did want to advertise our data services LibGuide here. This is in the process of being updated and cleaned up, but all the information on it is good. And so this will really walk you through all the information you need to manage and share your research data. And so here, for example, if you want to know more metadata, we have information about that. If you want to know more about documentation, we have information about that. We have a lot of information about licensing, sharing data, all that kind of good stuff. We do have information here for you. In addition, the guide does contain my contact information. So if you do have questions about data management or data sharing, you're always more than welcome to email me, like I said before, or schedule a research appointment using the link here. And really quickly, I did want to just advertise that the second Love Data Week workshop that had to be rescheduled, which was on finding and using public data sets, is now scheduled for Tuesday, February 28th at 12 p.m. Mountain Time. So if you have any interest in that, you're more than welcome to register. And of course, just like this workshop, if you cannot make the live recording, if you cannot make the live session for that, you're more than welcome to register and you will be sent a recording. And so that covered all of the things I wanted to make sure we touched on today. At this point, did anyone have any questions for me? All right, well, I'm not seeing any questions. So if that's the case, I'll let everyone go back to their day, and you can expect an email shortly with a recording of this presentation, as well as the slides, so you have access to all the links I showed off today. And like I said before, if you have any questions about data sharing, you're more than welcome to reach out to me at any time. Thank you.